Morning. Welcome to EUC5404, talking about delivering high-performance desktops with VMware Horizon NVIDIA Grid VGPU. I'm Pat Lee. I'm the Senior Director of Remote Experience at VMware, and this is?
My name is Luke Wignall. I'm the manager of the performance engineering team for Grid at NVIDIA.
So we're excited to sit here to talk to you today about Horizon NVIDIA Grid VGPU. Standard disclaimer, we could be lying through our teeth, but we're not, but just to make sure we cover ourselves. Agenda. I'm going to quickly kick off with a demo. Go into some of the understanding about use cases, talk about the products in particular, some ideas on how to really achieve the performance we're talking about, and then really thinking about how you architect a solution. There's a lot of things to keep in mind as you go down this path. And let's go forward. So we have an exciting topic. It's 3D, right? 3D sexy. It's exciting. So let's kick off with a demo to show you what you can deliver with Grid VGPU and Horizon. So this is actually recorded from the NVIDIA Grid test drive based on Horizon. This is a virtual machine running in at the San Francisco data center. I'm going to show you, this is what video playback with a GPU behind you can be. Very smooth, very fluid, seamless as you would expect. But that's not why you're actually in by little pixels. You're actually running this inside of a recorded VM. But let's talk about actually I can run 3D apps. So here is using WebGL, being able to play live and move seamlessly through a scene and move with 3D objects in real time dynamically.
But I think that when we have to talk about this, we want to talk about real apps. So starting with Google Earth, and again, I mean, we just embedded this real quick this morning in PowerPoint, so obviously not as beautiful as it was when we did it live. But again, it's the ability to zoom and move, and we did this we were in Palo Alto, and we were actually running this out of the Santa Clara data center. So,
here's ArcGIS, which is a very high-end mapping application used by governments. And you'll see how you can quickly pan and scan live motions of the entire city of Philadelphia, move seamlessly back and forth through it in real time. This isn't, this is something that can be done live. So if you're sitting there trying to figure out where to put in utilities in the city, you can zoom into a city, go underground, figure out what's going on all in real time in a virtual desktop.
And then, again, just sort of ratcheting up the complexity. This is AutoCAD, but it could be Revit. Really the same sort of expectation that you should be able to grab that model by the corner, rotate it, move it, shift it, and have it move and feel snappy under your cursor, if you will. And
here we're actually going to step it up. If you're a manufacturing firm, here is looking at basically Teamcenter, Siemens NX, to be able to look, even though it's only a small bike, the fact that you can actually interact with the model live in real time is pretty impressive.
And then last but not least, getting to the point of like a Siemens NX or something similar where you're really putting the greatest possible load in terms of app stack. And it's funny because as an NVIDIAN, it just drives me nuts when things aren't absolutely perfect. So this, of course, looked great this morning, and then we embedded in a PowerPoint, and then thanks PowerPoint. So anyways, a quick demonstration of what's possible.
And remember, 5 years ago, you couldn't do this, right? The fact that we're talking today that you can use VDI to deliver the highest end 3D desktops is a whole new world. And we're excited by the possibilities this brings. So why do people want to do this? So in talking to customers more and more, there are reasons why 3D desktops and VDI make a lot of sense. One, companies are more distributed than ever. You have companies who have worldwide offices, whether I'm in Asia and in Europe and in North America, and how do they collaborate worldwide? A great example is I was talking to a customer in the Midwest of the US, and they were working on a project in China. It was taking them 12 hours to copy the files from Omaha to Shanghai. They'd make 2 changes in Shanghai, and they'd copy the files back. They'd get 1 hour of productivity a day on this project, and they'd have to merge all the files. Not a great solution. Being able to all work dynamically at the same time live with VDI has been a huge boon for their business. If we start looking at things like contractors, if we look at some of the issues with customers who are working with multiple manufacturing partners, how do you make sure that your designs don't leak out? How do you have a way to be able to say, you can come on as a project for this month, next month, and then you're done with that contract going to the next one? Great. Kill their account today, they have no more access.
But the same could also be said about internal employees. It doesn't have to be just contractors. It's the ability to hire employees nowhere near where your data is. The talent might be in another country and you want that talent, but again, back to the earlier story, moving the data back and forth between that is just not effective. You just lose too much productivity. Now you can open up that HR, be able to hire anywhere, get the skill sets you need, and have that freedom.
So last year, we ran an early access program when we announced Grid VGP was coming to the VMware platform. We thought we'd have 100 customers who were going to look at it and kick the tires. We had over 600 customers who actually were evaluating it during the time period of the beta last year. And we learned some great things from those customers.
Yeah, so these are 5 actual customer stories. So this data is real, is my point. So yes, a marketing slide, right? But not really, because the first one is, in fact, an aerospace manufacturing company located in the U.S. They do a lot of military contracts and so on and so forth. Data security is very critical to them. Their problem was all about, actually, it's really funny. That story started with business resumption disaster recovery as their primary business issue. Grid walked in the door, got deployed with the rest of the virtualization stack, and solved BRDR immediately for them. They no longer had that issue. So the second thing they discovered as they did this is that on remote sites, so this is 2 satellite offices, not home users or anything like that initially. This was just a satellite offices. They saw a 70% increase in productivity for their top-line designers. So these are the most critical users doing the most critical work on the most critical applications, and they're seeing a 70% improvement in workflow. That was a staggering change for this company. They literally had to slow things down now. Instead of waiting for designs were hitting the rest of the workflow faster than they'd ever done before, and the rest of the workflow couldn't compensate. Another interesting fact from that particular customer is that on the local area network, so this is local, the main campus, they saw a 30% increase in productivity. Totally unexpected benefit on a networking level.
And that really is a big benefit, getting the data closer to the compute. That's a huge benefit you get with VDI, and especially as you start talking about these large files and large designs, that's something they don't plan for and they get a real big win from.
Oh, absolutely. In fact, let's go to the middle one, the 14,700 kilometers. Jensen, the CEO of NVIDIA, recently said that the laptops keep getting smaller and the data keeps growing exponentially larger. That simply mathematically doesn't work, right? We have a problem. And the solution is simply to move compute to the data, and that frees up the users, as he says, to roam around, right? They no longer have to be locked to the compute. And so that particular 14,700 kilometer reference was for an AEC firm, global AEC firm, using Revit. 2 teams, one in Holland, the other in Australia, but the important part was the data was in Atlanta in the United States and never left there. So they were able to collaborate from opposite ends of the globe, centralize data, and were able to respond faster than they'd ever responded to a particular project, and were able to achieve, in an industry that has sub 5% margins, 5 points of margin, so tight profit margins, they are actually able to see a significant increase in productivity and thus cost benefit. And then just to jump to the last one, we don't have time to do all of them. That's an auto manufacturer. That's the intellectual property story. So that's the story of not having to send my drawings out, my models, my parts of my car, not having to send those drawings out to parts manufacturers to create, say, a headlight or a wiring harness or some other part of the car. They're able to retain the ability to better negotiate pricing. So my original argument was, we're saving money for you on the hardware, on the desktops. You don't have to manage all these desktops. And they said, no, that's just going to cover the cost of the project. By being able to manage the cost better in negotiation, we will save tens of millions of dollars per car program. This is a year ago. They started 3 car programs in Q4 of last year. That's huge dollars. So these are not trivial advantages to customers.
Yeah. So I want to talk a bit about Horizon 6 and the features it brings for delivering high-performance graphics. So I'll give you a little bit of history about where we've started from the graphics perspective. As I talked about, these are use cases that weren't even possible 5 years ago. But we started making efforts 3 or 4 years ago to start improving our graphics story in VMware Horizon. So if we look at what we first did, we released Soft 3D, the ability to deliver 3D graphics, Windows Aero, to even task workers, because it was becoming more important to deliver a basic form of 3D even for the most entry-level users. And we did that with View 5 back in 2012. We later added VSGA, which is the ability to take advantage of an NVIDIA graphics card, but extend the virtual graphics stack of VMware Soft 3D to be able to use it with hardware backing to give you better performance and really help you with things like Office applications, WebGL, really basic solutions. Who in this room has deployed VSGA before? Let's see if hands.
Who's deployed VSGA? Show of hands.
Okay, a handful. But again, you see we're on the chart. It really is the low-end case. It really doesn't solve the highest-end use cases. So in 2013, we worked with NVIDIA to deliver what we call VDGA, the ability to do direct pass-through of taking a graphics card and matching it directly to one virtual machine. And that gave you the highest-end workloads. You could be running Petrel and high-end graphics, Maya, all on a virtual machine in a data center. It wasn't very cost-effective because it was a card directly attached to one virtual machine. It was like using a blade except in a VM. But it gave you the benefits of remoting, and that was something we saw some benefits from.
So VDGA, show of hands, who deployed with VDGA? A few more.
A few more people. But that wasn't cost effective. So we collaborated with NVIDIA on NVIDIA Grid VGPU, which gives you the benefits of looking at Grid VDGA with all the performance and reliability of the NVIDIA driver set with a dedicated card, but a more scalable solution where you can get up to 8 users per each GPU, up to 32 users per card. So you can leverage that in a more cost-effective manner. And that really does a wide variety of needs from the highest-end users, oil and gas, to lower-end users looking at things like medical imaging, where it makes a difference, where every bit matters.
Yep. Quick show of hands then on vGPU. Who's deployed VGB? That's good as well.
Yeah.
Awesome. Even more.
And one thing we just recently added in Horizon 6.2 is the ability to use RDSH applications, 3D applications and desktops for shared apps. So if you have some apps you just want to deliver a single app for, not a full desktop, let's think things like AutoCAD, potentially SolidWorks, you now have the ability to deliver just a single application with RDSH using Grid backing it for 3D.
I think we see a vision of the future where, and maybe it's not the future, maybe it's now, right, where users are consuming applications in a variety of ways. They have apps that need to interact and collaborate. Those apps need to be on a shared desktop for whatever reason. So you have this virtual desktop that's portable and has all of the various benefits that we're familiar with. At the same time, you're pulling in apps from maybe off-premise, cloud, RDSH, all these other solutions, and being able to deliver a full package offering with tremendous end-user experience. That to us is really the goal.
So we'll talk briefly about Grid VGPU. I'm going to leave the most of it to Luke to talk about as he goes more in depth on it. But the important part is being able to really share a physical graphics card across multiple users. It's a huge benefit for all of us what we're talking about. And it uses the NVIDIA drivers in the virtual machine, so you get all this highly available, lots of 20 years of R&D into it for native secure applications.
Tremendous amount of goodness with the Quadro driver, that's true.
And actually it really brings a lot of benefits about in terms of application certification, which we'll talk more about in a minute. I want to give you a quick comparison of the 3 grid graphics technologies we talked about, VSGA, Grid VGPU, and VDGA, and why you may want to consider each one. VSGA has been great for sharing from multiple users. It's good for lightweight graphics, but it doesn't support all the latest versions of graphics. It only supports DirectX 9 and OpenGL 2.1, which is relatively old, to be honest with you. So if you have applications that are more modern, which is the vast majority of anything with 3D, VSGA is really not going to meet your needs unless you're using things like Office. With Grid VGPU, you get the benefits of VSGA. You can share it among multiple users, up to 32 users per card. And you get fully scalable, reliable, certified application drivers with the latest DirectX and OpenGL stacks, DirectX 10, DirectX 11, OpenGL 3 and 4, all the latest graphics APIs. And new with Grid 2.0 is the ability to even use Cuda and OpenCL with the highest end profile, which is a huge benefit. One of the things that we did talk about in Horizon 6.2 is the ability to take advantage of this and actually do automatic placement. We'll go a bit more into that in a moment. Now, VDGA at the highest end used to be our highest end solution today. Honestly, you really don't need to use it with Grid VGPU 2.0. The use case has really gone away. You can actually take advantage of Grid GPU 2.0 and get all the benefits you would get with pass-through, but with more manageability.
And I think that's really the secret, right? I mean, the whole point of virtualization is this idea of flexibility and manageability and not having all this distributed physical devices. And so with vGPU, again, the goal is to be able to bring the scalability of VSGA, the high performance of VDGA, and everything in between while maintaining that flexibility, that freedom to be able to deliver, take back, recover resources as needed, depending on user need.
So to really validate the solution end-to-end, professional applications have always been certified by these vendors to only say this workstation with this version and this software stack. Now virtualization is one of the things they're actually looking at and they're actually supporting. So we have support statements from Autodesk for AutoCAD and Revit, Siemens for NX and Teamcenter, PTC for Creo, and Esri for ArcGIS Pro. These are fully certified solutions on top of VMware Horizon with NVIDIA Grid. It's a huge benefit, and there's more coming. I'm actually curious later when we actually get some feedback, is there other applications you'd like to see certified? But we're really excited to see that these high-end, super dependable applications that people rely upon are now certified on virtualized 3D stacks.
And what's interesting is what's pushing the ISVs, the software vendors, is customers. I can go to an ISV all day long and say, hey, we really want to see you get certified on VMware in for a particular app stack. But it's when customers go to them, say to Autodesk. For example, Maya is sitting on my desk right now waiting for our test results to get final certification, but it's the Maya team at Autodesk that's pushing against us because customers are pushing against them to get certified. They want that certification. So that's another one that's just around the corner as an example.
So we talked briefly that with Horizon 6.2 recently, we added support for 3D RDSH applications. So this works with the NVIDIA Grid VGPU or VDGA in pass-through mode and takes that ability to take that GPU and share it across an application workload, which is AutoCAD, SolidWorks, and others. So you can remote that application, a single application, or a set of applications, Google Earth, for example, and deliver it as a single application across your user base. It adds more flexibility, like Luke was saying, that a lot of cases you have multiple 3D applications, VDI makes the most sense. But if you have a single application you're trying to deploy Google Earth for a classroom, 3D RDSH may be the best way to deliver it. It's cost effective and simple. So it's a great way to think about how you can use these tools.
AutoCAD in a college setting, in an educational setting is a great example.
Right. So with Horizon 6.2, 6.2, we really made it very simple to make automation in 3D desktops really easy. So first and foremost, we added a couple new settings in vCenter to work with Grid VGPU. So in Grid VGPU, you actually go into vCenter and you create a resource pool. You take a bunch of servers that have grid cards in it, and you build a cluster out of it. And once you've built that cluster, you go in and you say, I'm going to create a profile, I'm going to create a VM with a profile for each graphics card you care about. And then in Horizon, you basically then create a pool in Horizon. Who in this room's deployed Horizon with 3D desktops?
Show of hands.
Handful, okay. So you just create a pool, and at that point in time you point it, you say this is the VM I want as my base image, and you say when you create new VMs, point it to the cluster. And at that point in time you say I want to create 50, 100, 200, 500 VMs, and Horizon will automate building them for you based upon the resources available in the cluster for you. So it builds them, fills up the first server, when that server's full it goes to the next server in the cluster, builds out the VMs, and keeps using all the hosts in the cluster until they're full.
And then vSphere also applies some logic as well in terms of distributing. Maybe touch on that. I mean, I think that breadth versus depth is a key piece from a performance standpoint. It was a big decision.
So one of the things we decided to do is that instead of trying to maximize the density on the host for the maximum number of hosts, we want to maximize for performance. So we place the VMs across the host first on different GPUs, so you get the best performance possible. You can change that setting,
correct,
but the goal was to optimize for performance when you're going to deliver these desktops first and foremost. But one of the great news about the automation and provisioning is if a host goes down and the server dies in the cluster, the next time the user goes to log into that VM, it'll automatically move it to a different host in the cluster and power it on. So you now have a set of availability and failover you never had before with a physical workstation. If a physical workstation died before, you would go and order a new one, try to rescue data off the hard drive if possible, get them up and running. That could take days. If a server goes down in this case, it'll come up in minutes because it'll take advantage of other hosts in that cluster and bring it up automatically for you the next time I log in. It's a whole new level of availability you never had before.
Yeah, we're going to touch on this in just a few moments, but that also changes the support requirement, right? We've gone from individual users with individual workstations to now aggregating users on hosts, centralizing them in the data center, which changes your support requirement, right? You're now going to the same thought process you have with server VMs about uptime, 5 nines, things like that. We'll touch on that in a moment.
Another benefit that Horizon brings is the ability to use app volume, so you can actually make application delivery much simpler. If you look at these high-end applications, if you look at a Revit, you look at a Cuda, you look at NX, these are large, complex applications that are hard to deploy. With app volumes, you can build app stacks and easily make it so you just with one click, you can update each of those VMs next time they update without having to use complex patching mechanisms that may be insecure. With app volumes, in one click, everything's updated the next time I log in. seamlessly.
Think how this changes the way that workstation users, as opposed to say, business PC level users. So knowledge workers, when we start talking about power users and designers, they've always had an incredible amount of operational just demand, right? They need a lot of attention, they need a lot of configuration, and all of a sudden you're taking these advantages from VMware, the advantages of VDI, right, and applying that to a user group that typically has been very high maintenance and simplifying all that. This is incredible value.
So we hand over to Luke now to talk about NVIDIA Grid and Grid 2.0.
Yeah, so let's dive in just, since not everybody raised their hand earlier. The premise is relatively simple. All we've done is we've just like we've added CD-ROMs or whatever else in terms of a physical device into a virtual machine host, right? So that host server now gets a couple of our GPU cards in it. If it's a blade, it'll get one of our or more of our MXM modules. That GPU sits in there available as a resource no differently than any other resource that's in that host, right? CPU, RAM, system RAM, you name it. The key piece to this is that thanks to the ability to put a VIB into vSphere, creating our own little piece of that hypervisor that manages access to that GPU, we now have direct communication and can run, as Pat said earlier, run our NVIDIA driver within the guest VM, allowing it to communicate directly to the physical GPU for maximum performance. That's where all of that goodness, the ability to run Quadro, the ability to get that high performance comes from. So that's a key piece. Without that, if I take that away, if I break that chain and we go back to, say, VSGA and the more limited API access, what you get is on the left, right? That blocky, just sort of old school, inefficient looking graphic that really doesn't represent the product. On the right, I have something that's smooth and has the actual shape of the object. An engineer is never going to be accepting of what's on the left. They're going to want what's on the right. So that's absolutely critical. They also are going to demand really what's been decades of working very closely with the ISVs to provide a tremendous amount of performance that directly impacts the application. In other words, instead of just creating a high-powered GPU and creating a really good driver, first of all, who here thinks we have a small driver, right? It's a huge driver because it's an application. It's an application that the ISVs lean on in order to get the best possible performance out of that GPU and thus out of their app. So things like anti-aliasing, so that I can blow up that drawing and that edge of, say, the fender line on a car doesn't become all jagged and pixelated. Instead, it stays exactly as a line like I would expect it as I get closer to it. The ability to do things like photorealistic imaging so that I can show that, say it's a car, I can show that car anywhere in the world instantaneously and it looks like it's there, but it's not real. But that gives me the ability to very cost effectively show that car to investors or prospective buyers or whoever, and in a very realistic sense. So Quadro is something that is absolutely critical to those engineers and designers, power users, really everybody can take advantage of it. So what is Grid 2.0? So we talk a lot about 2x now. Who here has deployed with K1 cards? Show of hands, K1s. Large number. How about K2s? So let me introduce Maxwell to you. K1 and K2, the K stands for Kepler. That's our now, I guess, older, if you will, architecture. Maxwell is our next architecture. The whole point, as in all things with NVIDIA, is we want that next level of performance. We never, ever grow tired of delivering that next level of performance. So with Maxwell, we've been able to deliver twice the users. And it's funny because we've had this big debate internally about twice the users, 2x users, or 2x performance. That's not entirely true. Basically, if you understand back to that slide that showed that stack, during your time slice session access to the GPU, you get all of that GPU. So all 3,000 plus Cuda cores that are on a Maxwell card are yours for your session. However many microseconds that session is, you have that full power of an M5000 equivalent GPU, so you do get twice the performance. And I'll show you some numbers here in just a second. And then, of course, twice the platforms, because we now do have an MXM module in the M6, and the M6 gives you the ability to now do MXM-style blades instead of sidecars and so forth, which is what we've had up till now. And then 2 times the OS because we've added, thanks to Pat's team, Linux. Who here uses Linux in their current environment? Hands shot up immediately.
So we're pretty excited by this. We announced VMware Horizon for Linux this summer, and we had support for direct pass-through graphics then. But with Grid VGPU now, we have the ability to do more cost-effective GPU sharing, use up to 4 displays, and give you a really rich experience.
And manage it all in Horizon, which I think is the key thing. No longer is it that one-off. So let's get into the nuts and bolts a little bit, and I'm going to speed it up a little bit because we're going to run out of time, and we really want a chance to have questions and answers. So here's the M60 and the M6. Notice we've doubled the amount of a video RAM of frame buffer, so we're now at 8 gigs per GPU instead of 4, which is what we had on the K1 and the K2. Notice the number of Cuda cores, a huge increase in Cuda cores. I said 3,000 a minute ago. I was wrong. And then, of course, the number of channels is doubled as well. So now we're getting up to 16 individual desktops, one per channel, per GPU. So with an M60, 2 GPUs, I can have up to 32 individual desktops, assuming the rest of my resource pool will support that. Again, notice the power requirements, okay? Very, very critical. We said this before with the K1 and the K2. We'll continue to say it with every subsequent card, including Maxwell. Certified servers only. These are passively cooled cards. They are extremely power hungry. Turn off the energy efficient setting in the server and allow that thing to run at high performance. Notice that the M6, because of the power requirements of blades, it's slightly lower powered than half of an M60. So notice the CUDA core count is not quite half of an M60. And that, again, is just because we are limited to 100 watts in order to maintain the power efficiency within a blade server. Yep. So what does this mean in terms of the lineup? So now we've got K1s, for those that raised your hand. We've got K2s, for the rest of you that raised your hands. And now, for those users that need that additional frame buffer, that next level of performance, as well as, and I'm going to get into a little more about this, the support that needs to be offered. Things that are being asked for by customers are, you've asked me to move my workstation users, those critical users, critical apps, critical users, critical work, into the data center. We want full-time support now. So NVIDIA is ramping up full-time support. We've also been asked, we would like to see you decouple software and hardware so that we don't have to upgrade like we do with the Quadro cycle. We want to be able to upgrade software or hardware depending on our situation and our need. So we're decoupling software and hardware. We've also been asked for a tremendous array of features, things like motion. Who here wants motion? vMotion with vGPU. Interesting, I would have thought more arms. I will tell you that is incredibly hard to do. How do you capture a frame buffer and move it without an end user noticing at 60 hertz? Not an easy task, but something we're working on. So by decoupling, we're actually in a position to be able to work through those sorts of challenges and get those features without being stuck in a hardware refresh cycle. Does that make sense? To us, based on customer feedback, that's one of our most important changes in NVIDIA. Now notice the profiles. We've added an 8 gig profile. And you can see which cards support those. Obviously, the K1 and the K2 do not because it just doesn't have sufficient frame buffer. And still, as we've talked about in the past, you evenly slice up frame buffer per GPU. So if I assign a 1 gig profile, I can only assign 1 gig profiles to that GPU. The next GPU, I can assign a different or the same profile. So let's talk a bit about scalability. We've been talking about performance. ViewPerf is a fairly standard Quadro test that really hammers the GPU. I have an inherent problem with ViewPerf. Great test for beating up GPUs. However, it does not open the app. It does not open a file. It does not act like an end user. So when I scale that in testing at our performance labs, it doesn't scale like an end user would scale. So if I go from 1 user to 4 users to 8 to 16 with ViewPerf, all I do is run out of GPU, but I'm not really running the rest of the system the same way an end user would run it. So we initially ran that test with 1, and then we ran it through a scale test, and we actually got 2x. We got double density on ViewPerf, which is amazing. We didn't expect that. So then we went to Esri ArcGIS Pro and actually ran using their benchmark tool, a very mature benchmark, I would say. And we ended up with these results. So here's your 2x. We've been asked many times on the previous slide to have put numbers in there, and I thought you'd like to see raw data. This actually got completed last night in my lab and sent to me this morning. So the first thing I noted is, what is with the approximately 2-second difference on one VM? So of course I'm speaking to engineering to say, why is there a 2-second difference? We want better. We're not satisfied saying maybe that's just an aberration. But notice, draw time sum. Who's familiar with the Esri ArcGIS Pro Benchmark? So basically the premise is there are 11 tests, subtests. It moves through a series of bookmarks within Esri through that the Philadelphia map that you saw in our demo, and it basically scores the amount of time it takes to render each of those bookmarks. That total length of time is called draw time sum, and the current test with a 5-second think time, which means it waits 5 seconds, which we believe is very close to human behavior. I'll click a bookmark, wait for something to happen, click a bookmark, that's at 5 seconds. I end up with double density, 16 users in essentially the same amount of time it took to do 8 with a K2. So, real data. And then I'm going to plow ahead here. As Pat has already commented, great new features, Linux, Cuda. Who here uses Cuda or OpenCL currently in their workloads? A few, and that's what I would expect. Very, very high-end users typically. Notice the additional profiles we already talked about and the up to 16 users. Let's go to the next one. But what we've changed is the ability to not just think in terms of profiles, but we've also, thanks to customer feedback, we are now focusing on because you guys put users into buckets, you define users by the kind of workflow that they have. It's a high or medium or low user. For Esri, for example, I would have a high, medium, or low 3D user with Esri. And so what we've done is we've defined within those buckets a virtual PC user. That's a knowledge worker, usually. But when I talk to an AEC firm, they'll tell me that only AutoCAD users are knowledge workers to them. But when they go to Revit, they refer to them as a power user. So the Grid Virtual Workstation brings in Quadro. There's no Quadro in the virtual PC, but on the virtual workstation and the virtual workstation extended, I add the benefit of Quadro to the driver. So I'm adding power as this goes up. So if I'm architecting a solution, the way I might look at this is, I have 1,000 users, let's say. Of those 1,000 users, maybe 500 or more might be virtual PC users, because they need GPU, but they don't need a ton of GPU, and they don't necessarily need Quadro for the app stack they're using. On the other hand, I might need another 200 or 300 users that do virtual workstation because they're power users and so forth. And then I have a small number of designers, so I would buy maybe a small number of the workstation extended license. Now I have flexibility within the amount of driver and the amount of application and software delivery from NVIDIA that you're giving your users, as well as I still have those profiles, those vGPU profiles, to define the amount of frame buffer. So I have 2 ways to be flexible now in deploying my users.
So I want to talk about now we've talked about the products and a bit about the background. Let's talk about what you actually do to actually size virtual desktops for success. So this isn't your mom's VDI, right? This is not 200 users on a server. It's a very different world. The density's down. You may get 15 users. You may get 20 users on a server, and everything else goes up. A lot more vCPU cores, a lot more memory, IOPS, graphics. It's a very different world. As you plan these out, you have to be planning very differently. And you're not getting a $250 virtual desktop. You're getting something that's a virtual workstation. You have to plan appropriately for it. So some things to keep in mind as you start sizing these. Now, we're going to go into some more details on specifics, but some guidance to help kick you off in your thinking about as you plan this. One, they have to be on the latest hardware version. vSphere 6 and hardware v11, you have to do that to support Grid vGPU. Now, vCPUs. 2 is the bare minimum. Now, some people are doing that with AutoCAD, but we'd recommend probably closer to 4 to 6 for a typical use case. Now, and we'll give you more details as we talk a bit about this, but this is sort of a starting point for your thinking about if you're going to start building your own pilot, things to consider. RAM, 4 gigs is the bare minimum. We see some users doing it, but you're really starting at 8. I talked to a customer last month who needs 128 gigs of RAM for a virtual workstation. These are, again, not small. This is big.
Think about this. If you're dealing with oil and gas, that workstation that you're trying to move into the data center might cost, a Z840 fully loaded with Xeons with 128 gigs of RAM and a couple of our graphics cards is what? $25,000 US? I mean, these are expensive workstations. So if I get 4 of those on a host, I'm saving some serious money.
So realistically, you're probably going to hit minimum 8 gigs of RAM for your typical users. Now, your OSs, you're going to be running 64-bit Windows or 64-bit Linux. It's a given, but some people, just think about it, don't try 32-bit at all because they all need more memory. You got to plan appropriately for this. Now, a couple things we keep in mind, especially with Windows, you don't want to just take the base install of Windows and put it in a virtual machine, even in this use case. You want to think about optimizing some things for Windows for a VDI environment. So we have the VMware OS optimization tool. I highly recommend checking out this fling we have. It'll help you optimize the tool to make sure it works best in a VDI environment. I do want to drill down on one specific topic, which is storage. In the years we've been doing VDI, storage has typically been the biggest thing that causes failure in VDI environments. And it's even more critical when you start talking about 3D. These customers have much higher IOPS requirements than a knowledge worker.
Much larger files.
Huge big files, huge amounts of storage requirements, high performance. These guys have SSDs, they have dual SAS RAIDs in these $10,000 workstations. So you need to think about what you do to deliver this. Virtual SAN is a great way to do it with all flash with virtual SAN. We have customers looking to deploy today. It's a great way to actually just add another 2U server to your rack, get more storage and automatically scale out, or look at things like an all flash based SAN. There are lots of options out there, but you need to think about high IOPS. A good example is, as we were going through and helping qualify some of these applications, we helped Autodesk come up with some IOPS requirements for some of these apps. Revit's a great example. We recommend a minimum of 500 IOPS per user for a Revit user, based upon their requirements for their application. So you need to be thinking about the number of IOPS you deliver to be successful in this environment. So now let's talk about some specific applications.
So everybody asks the same question. If you go to our booth today, you'll hear it all day long, and that is how many users for a specific app, in this case, Esri ArcGIS Pro, how many users per server can I expect to get? Where do I start? That's what customers always ask us. And so we've put together these app guides, and the URL's up there at the top. This one for Esri, and then we'll show you a Revit one next. We also have one for AutoCAD. And the idea was sort of like a car, right? City, highway, mileage. I expect to get different mileage if I'm at a peak workload. I should expect to get a different mileage, if you will, if I have, say, more normal worker behavior. And so the 10 and the 16 represent that range. And you'll notice that the profile and the builds are the same, and the server in the center is, in fact, the hardware we ran this test on. So with this app guide, I can give this to a customer and say, if you buy that platform and you run their benchmark, you will get those results. We've proven it over and over and over again. And that's a great starting point. So now customers can adjust a little bit to the left or the right and expect that sort of density. Yes, we're working on Maxwell results for these as well, and those will be coming out shortly. And then let's jump to the next one.
There, I just did. That's Revit.
Oh, sorry, Revit. And they look so similar. But notice this time that the profile changed. So with this one, we were able to drop in density. That's why we were able to jump to 24 users per host, because quite frankly, when you start spreading out think time and really offloading the amount of work that a user is doing at the same time, in other words, on a peak workload, we really hammer that server. In other words, everybody is like a robot. They walk in, they simultaneously sit down, they work, they open their file, they save their file, they close, they walk out, all at the same time in unison. Users don't do that, right? So that gives us that peak 12 versus 24, where we start adding think time, staggered starts, and other flexible.
I think one thing to also keep in mind, as I mentioned on your vCPUs and RAM is much bigger. Look at this for the balanced workload. 4 vCPUs and 8 gigs of RAM is for an average Revit user.
Yep.
And the high-end user, 6 vCPUs and 16 gigs of RAM, right? These are very different virtual machines than we've built before.
Yeah, and as Pat said, you don't go into this expecting to get to 100 users on a host. You're not. I mean, your goal is, and our goal at the Performance Engineering Lab is to find the best performance and scalability. That's the challenge.
So I want to talk a bit about how you get up and running with a proof of concept and be successful. We learned a lot in the last year, especially as we did the Grid Early Access Program last year. You said we had over 600 customers. We learned a lot from those customers. The biggest thing that came up early on is like, this is really complex. So we wanted to prove that wrong. So back at GTC in March, we started a very friendly contest between VMware and NVIDIA. Can we stand up 60 desktops in 60 minutes? That means installing vSphere, installing vCenter, getting it. The only way we cheated was we actually built the VM already. So we built the VM template. Everything else we had to do, we had to install from scratch.
It was bare metal.
Now, it was a fun contest. Some other company won. NVIDIA won.
He's trying to avoid the fact that NVIDIA did in fact beat VMware by
6 minutes.
6 minutes.
But still, both teams proved in an hour you could stand up 60 desktops, which is impressive. But that's not the hard part. So like all the stuff in blue is what we did in 60 minutes. We proved we can do this. But the biggest thing when you want to be successful in deploying VDI with 3D is there's a lot of things you have to consider as you really want to make a proof of concept. So the first thing, most importantly, is you have to understand your business drivers. If you don't understand your business drivers, you're not going to have a successful program. We've learned a lot from those 600 customers and some great stories about things they learned. We've talked about some of them earlier about I gained 4 hours a day and 4 hours a week back from my engineers because it became faster. That became a huge driver for them. But thinking about what your business drivers are and why you're doing this is critical. You can take a few weeks up front to actually help develop that. And if you don't do that, you're not going to be successful. Then you need to actually determine what's your scope of a proof of concept. You can't do this without testing this. You can't do this without deploying it initially in a proof of concept to understand your deployment model. Make sure you define success criteria. If you don't understand what success is, you can't measure it. You can't get the buy-in from your business to deal with it. But after you do that, then you have to buy hardware, right? We told you can install it in 60 minutes. You still got to get a PO. You got to get budget. You got to wait for the servers to come in. You got to get it racked. You got to get IP addresses. There's a lot of things you keep in mind as you go do this. And then once you get those servers and they're racked, then you can actually just install the software and do this configuration in a few days. It's not very hard. The great news is that we've actually done some stuff to help you. There's an NVIDIA Grid deployment guide with VMware Horizon. It's over 200 pages, and it's 200 pages because there's a lot of screenshots. Every process has got a screenshot attached to it. It's not that complex. If you want a picture book, you've got it. It's available for download. I highly recommend taking a look at it.
I wrote it for me. In other words, it's every screenshot, so I can go next, finished, done.
Exactly. It's really critical. But then once you've got the installation, now you have to do a pilot. You have to get those users start testing. You have to pick some of those picky users, those ones who are going to be a pain in the ass, the ones who are going to sit there and hold you accountable. Find the ones who've got great credibility in the business, because if you win them over with this, you'll be successful.
Right.
Then run your pilot and measure your results, right? This is something, you got to measure the results so you can actually go back to your management, lay out the success criteria, and figure out next steps. Now, I'm actually curious when you get some questions what you guys feel about this. You get these slides, take this roadmap, look at it. We're really fascinated to see if this is something you see in your approach to how you did 3D.
We'd like to get this validated. Let us know if we're wrong. I mean, so far customers have given us some of this information, but the more customers that give it to us, the more accurate that information will be. So if you disagree with something, please let us know and tell us why.
So these next slides are a little bit ironic at this point. Dell's a very important partner to VMware, and actually we did these slides back in San Francisco, so it wasn't put in yesterday. So the funny thing is that they have a pretty big graphics investment, so I'm going to quickly talk about two things. I recommend going to their booth, not because they bought EMC yesterday, but they do have great graphics servers they use, and they've actually built some appliances that are pretty interesting. They built what they call the WISE Data Center for VMware Horizon with Grid VGPU, so they have the ability to build specific appliances that they are allowed to roll out that have Horizon pre-installed, the ability to actually just turn on a VM really quickly and get it up and running. So I highly recommend going by their booth, take a look at what they've got. They get some interesting things as well as some other partners. But now I want to actually wrap up and get some questions from you guys.
So we have a couple of microphones available, and while those get brought out, and please start raising your hands if you have questions, but we wanted to close with some quotes from actual customers. I'm certain you're all familiar with Airbus. You probably flew on one to get here.
And by the way, before everybody leaves, we have a session at 5 o'clock today actually interviewing Airbus and interviewing AECOM to hear about their deployments of 3D in this room. So if you want to hear more about from customers' perspective of what Horizon and Grid VGPU bring you, 5 o'clock in this room, come back and hear from actual customers, get their feedback. It's not just talking heads at that point.
Exactly. Any questions at this point?
Microphone coming to you.
Thank you. I'm working for a medical company, creating radiation software. Compression is essential for deployment.
Okay.
What are the options? Or actually, compression is actually not of an issue for us. We need lossless compression. What are the settings within Horizon?
So with the PCRP protocol, we have a lossless option. You can actually, currently it's built a lossless. You can go turn on the options so it is completely lossless. You have that ability to go change that in the protocol. And you can go look at the PCRP deployment guides for more details on that. But that is an option today, to go completely lossless.
And perhaps another additional question. We also have computation on GPU. Is that also available within the Grid 2.0?
Yes. Up till now, you had to use VDGA in order to have Cuda or OpenCL. Now, with Maxwell, you also have that largest 8 gig profile, also includes the ability to run Cuda and OpenCL. So if I have a user, say I have a general pool of users, and then every so often I need to do compute, I can just spin up a VM, attach that profile, and now I have the ability to do compute through vGPU. We actually have a really great demo that I wanted to try to include on this. It's just too long. So maybe swing by the booth and I'd be happy to show you. It happens to be oil and gas, but it's a compelling video.
Okay, thank you.
Question?
Up front, wait.
Hi. My question is, how do you measure the performance that this graphic card is offering to the user on the server side? How can you measure how much of it is utilized by the users that you have there? How can you ensure that if you get the feedback that the performance is good or bad, that is the same?
So one of the challenges that we have, I'll fully admit, one of the challenges we have right now is that NVIDIA-SMI. Are you familiar with that tool? SMI. So loaded with every one of our drivers, as well as the VIB, you'll find a tool called NVIDIA-SMI, System Management Interface. It's a ASCII-based command line tool that allows you to pool down to 5-second intervals data from the GPU. How much of the GPU is in use, how much frame buffer is allocated. Notice I didn't say how much frame buffer is in use, and those sorts of metrics. So you can pull those, you can dump them to CSV, Splunk, whatever. That you have for some sort of aggregate tool. The challenge we have, I admit this, is that we need that tool to also take it to the next level and show us which one of the guests is creating that kind of load. This is something that, again, why we're decoupling is to be able to focus on those sorts of management tools. But that will at least give you some initial data points. So we just will make it more accurate. Good question.
Down in front.
Microphone.
Down in front.
I'm just wondering, the oil and gas sector is getting more cost concerned. So I'm wondering the pricing models for the licenses, will they be flexible in some kind of way, and will partners be able to kind of sell them at a loss, to say? Because this adds cost because the workstations are already expensive and the graphics cards are even more expensive.
So we're working closely with, just as an example, I mean, obviously we're working with all the ISVs, but Schlumberger, for example, with Petrel, I'd really like to do an app guide for Petrel because we have everybody, I think there's a UK university that's currently using K1s, but if I go talk to a Houston oil and gas company that's doing some of their largest rendering, they want more than a K2, so they're excited about the Maxwell cards. So it runs the whole gamut, and where do I? But that's the whole point, right? The whole point is I have an ability to I can qualify my users, determine what it is they really need using tools like SMI as well as whether it's VROPS or whatever to figure out how much they really need, and then I can assign that. And if that changes, I can give them more, or I can take it back with that flexibility. And the same thing with the licensing. Once I figure out my user pool, I can just buy the number of licenses that I need for individual desktops. So if I just easy math, if I have 100 users but I make 70 desktops because not all users are on all the time, I'm going to buy 70 licenses. Of those 70 licenses, I'm not going to buy them all at the highest end because some of my users might be on K1, some of my users might be on K2s, or they might be on more entry-level vGPU profiles for Maxwell. So now I have that flexibility.
Have you looked at the option to have a flexible as-you-use license then? So if a customer starts out with the lowest license and he sees more use needed, he can pay as he goes?
You're not the first person to ask that question, so we thought we came up with a great answer, and now you've added more questions to it. So it's in discussion. But yes, we understand. A question that you suggest but aren't asking that we've also heard from customers is, what if we went to flexible frame buffer? What if we could over-allocate frame buffer? Dynamic allocation, that sort of thing. These are features, again, why we're decoupling so that we can focus on that level of flexibility. A question in front here?
How long will K1 and K2 still be available?
There's no current end of life. It's one of those things, right? Somebody could call me tomorrow and say, we've decided end of life. And if that were the case, it would be months. We wouldn't end of life tomorrow. At the moment, there's no expectation to do an end of life near term. So the K1 and the K2 still have plenty of value. We understand that there are people deploying that and that these are cards that we're still exploring the amount of benefit. The problem is, like anything else, the apps continue to grow, the data continues to grow, the compute demand continues to grow. We have users running ANSYS that are desperate for bigger than 4 gigs of frame buffer. We have Maya users that want Cuda and the ability to do compute and graphics at the same time. So we have to continue to innovate, but we also understand the rest of that.
Very different customers.
Oh, absolutely. Yeah, nope, totally get it. But that's not, right. And that's why there's no end of life currently scheduled.
Other questions?
Great questions. Any others? Hands?
So on a couple quick things as we close out. The demo we did earlier was from the NVIDIA Grid test drive with Horizon. You can go try it yourself. Go to nvidia.com/VMware-trygrid. You can go get an account and play with up to 4 hours. If you want to quickly show off 3D graphics to a customer, a partner, your internal boss, it's a great way to do it. The data center's in Amsterdam, so it's in Europe, it's nearby. There's also one in the US and one in Asia, but the one that's important here is Amsterdam, so you get high visibility. I was using it in the hotel room last night, it was working great. So it's like trade shows, but different story, but it's
But I would also challenge you that if you go there, you can actually select from the other server locations, host locations. So if you want to test from here to see what it would be like, what the experience would be like to Asia, log into Asia and run a desktop there. Get a sense of that length of, that speed of light latency. It's a good test.
One other thing to recommend, if you actually are interested in 3D graphics NVIDIA, go try out the NVIDIA VMware community on NVIDIA's website at nvidia.com/NYC. It'll let you actually interact with VMware and NVIDIA and get more feedback on what you're trying to do and deploy.
Please.
And some resources that are available to you. These slides are going to be available to download after the show, but it's important. There's a whole lot of documentation that we've created to help make you more successful. We mentioned earlier the grid deployment guide with Horizon. We have the Horizon 3D engineering workload reference architecture, plus the app guides. There's a lot of stuff out there. Highly recommend these resources if you're going to plan this in your own environment. So any last questions? Thank you all for attending.
Thank you very much.
Appreciate it.